we just looked at this layer of packaging. We can of course always go one step further into another layer or level. And what if we had one of these whole things here? No, I mean the whole thing here. One whole of these for each finger on our hand. We could package those together, and then we could take those packages, and one for each finger on our hand, we could package all those together, and we could end up with something like this. Now if you look at this picture and say, wow, that's beautiful, look at the structure there, look at the nice patterns to it, then you're thinking like a mathematician. See how if I take this picture, if I zoom in, it looks effectively the same. If I zoom in again, it looks the same at this zoom level, or at this zoom level, or at this zoom level. It has this self-similar structure where it looks the same all the way zoomed out as it does all the way in. And see how nicely lined up all of these tons and tons of so many little dots are. And when they line up and you look at them kind of zoomed out like this, all the little dots next to each other, now they kind of start looking like their own little blocks. And those blocks then start looking like, when you organize those blocks together, it looks the same as it did if we had just, boom, all the way inside of there, packaged the dots together. As we've said all along, math is the study of patterns. So if you look at this kind of pattern, just like any kind of art where you would see patterns and structure and say, that's neat, or even that's pretty, it's beautiful in some way. And mathematicians love to talk about that. One of the best compliments that mathematicians give each other on their work when they've written a paper, when they've written a proof, is to say, oh, that's an elegant proof, it's beautiful. And they're using the language of art, of aesthetics, things that are attractive because of their order and structure, and patterns. So if there's anything about a picture like this that makes you say, oh, that's neat, that's interesting, it's pretty, it's beautiful, then you're thinking like a mathematician. Doesn't matter if you're good at adding fractions or solving algebraic equations or whatever else, trigonometric sines and cosines. If you think patterns like this are interesting and pretty, then you're thinking the way that a mathematician does. By the way, I didn't include this picture on the handout PDF files because I think it would drive a printer crazy if you tried to print out those pages and had one like this with all of these infinitesimal little dots on it. But I've included this video where we could zoom in and out and just see what the nice structure it is to it.